Here, if you see the annexure B talks about the thermal conductivities of commonly used construction materials. Over here clearly it is mentioned that aluminium, mild steel, window glasses, everything if you see over here, it is clearly mentioned over here. uh, so you can use over here all these things. These values can be clearly used wherever you have to use the thermal conductivity of commonly used construction materials. So this is the table which you want to refer, you can refer. Here annexure C talks about special considerations for mechanical control rooms, and annexure C, if you see, it's clearly mentioned section C.1.2 occupancy. Number of persons to be allowed in the machinery control room should be 3 unless and otherwise stated by the purchaser. That means when you are doing the heat load calculation for the machinery room or a machinery control room, it should not exceed more than 3 people. And total heat transfer coefficients of the control machinery control rooms also are clearly given over here. You can use that while heat load calculations. That U values specifically we call about the control room bulkheads and ceiling against the engine room should be taken as the 0.8. Then the control room floor against the engine room is 1.2. Then windows triple glazing value is to consider 2.5. So these are the values you can consider while calculating the heat load. Then section C.2.3 talks about heat gain from lighting and other sources. It talks about that heat gain in the control room, basically mechanical control room in the ship, can be taken as 10 watt per meter square for the lighting, and you can put this value in the heat load calculation. Similarly, for this heat gain from the equipment should be considered as 7 kilowatt. So wherever the values are not specified by the vendor, we can go for the 7 kilowatt value, and you can start the heat load calculations over there. No need to assume anything, because 7 kilowatt is already been mentioned. So you are on the safer side. You can clearly mention that 7 kilowatt value is not from the vendor yet. So 7 kilowatt as per ISO 7547 is been applied over here. So you are safer from the calculations, and you don't have to wait or stop for anyone for the calculation purpose. There are some special considerations for the wheelhouse as per Annexure D. As I explained earlier, wheelhouse is nothing but your deck. Deck is nothing but your topmost level where your captain is navigating the entire ship and giving the instructions by sitting there. So this is also very very important and the heart of the ship, because captain is navigating everything and all the controls are there, and one command he can find everything. So if you see in Annexure D, section D.1, heat transfer coefficient shall be 0.5 watt per square meter Kelvin. Then section D.1.2 is occupancy. Number of persons to be allowed for the wheelhouse shall be 5. This occupancy has to be 5. Then the heat gain from the lighting and other sources, heat gain in the wheelhouse has to be ignored. The reason is that because the wheelhouse has lot of glasses so that captain can see through. So lighting load is reduced because you have a lot of lights already from the sun which is coming from that particular glasses. So it can be easily ignored. Where the heat gain from the equipment operation is not specified, we can take it as a 2 kilowatt over here. So these are the various values. So 2 kilowatt is the heat dissipation you can take from the control panels. And what is mentioned is the air has to be positive pressure system has to be there. The air has to be, or system has to be the positive pressure system over here. So it has to be 50 pascal to be maintained inside. So this is the typical values of the wheelhouse. Wheelhouse will find in almost every ship, because the captain or whoever is controlling the ship has to sit over there. So these are the factors while calculating the heat load you have to clearly consider in the calculations to arrive at the realistic figure. And I already explained why the lighting load can be neglected, because there is already a lot of glasses surrounding the wheelhouse, so that captain can have an overall view of every places. And as I explained earlier, when the glasses are more, definitely the solar load is going to be more. So this factor anyway gets offsetted by the solar load. Let's go to the next slide. As you could see here, the annexure E talks about the special consideration for the dry provision rooms. The dry provision room is nothing but the room where you need to keep your pickles or your rice or your or your wheat or your papad, whatever it is, whichever doesn't need a refrigeration system, you can consider here in the dry provision rooms. So what is dry provision room all about is it has to be it is a part of the ship, and as I explained earlier, these are the things you can keep in the dry provision store. This is very important because this is related to the food. So it should not get spoiled, because otherwise the crew which is on the ship, they will not get proper food. So dry provision room, it clearly mentioned that it should be dry, cooled, ventilated. That means the air conditioning has to be provided in this particular room, and it has to be dry, cooled, ventilated. Air supply to the room should be diffused in order to avoid excessive drying of the stores exposed to the direct jet of an air relatively high speed. Even distribution of air throughout the room should be arranged, and ducts serving this particular room should be adequately rat proofed, stated by the purchaser. Rat proof, the food is there, rat is there. Normally in marine this situation never arises, but by chance suppose you are onboarded to a particular port, and suppose the rat enters through that, then your duct should be the rat proof, otherwise rat will go everywhere in the ship through the ducts. So it has to be rat proof. Then section A.1.4 talks about the outdoor air. The minimum air quantity should not be less than 50% of the total air. This you need to consider very, very carefully. And this question often asked in interview about what is the specific about a dry provision room. So don't forget about this rat proof and 50% of the total air supply. The number of occupancy you can take as a 1. Even if you take it as 0, it doesn't matter much, but take it as a 1 as specified. And if you see the supply airflow quantification, the supply airflow in the dry provision room shall be calculated based on the following one. It should be either 6 air changes per person or 0.008 meter cube per person. Obviously 6 air changes will be always higher, so just go for the 6 air changes over here, and you will be arriving at the required design of the dry provision store. So if you see in dry provision, occupancy covered, outdoor airflow is covered, supply airflow is covered, there is no heat dissipating equipment inside, you can simply neglect it. So everything is covered, so you can put these values and arrive at the heat load calculation for this particular room. With this, we are coming to end of this module ISO 7547. In this module, as I explained earlier, mostly was all focused on the marine, that is ships, and air conditioning guidance or the standard related to the ships. What are the air changes to be considered, U values to be considered, occupancy to be considered, then how many people per square meter to be considered, how to arrive at the fresh air flow, how to arrive at the exhaust flow, how many air changes we need to consider, then how the U value we can arrive at, how the solar load we have to arrive at, and how what is the supply air temperature we need to consider, what is the kilowatt heat dissipation we need to consider, what is the motor kilowatt rating we need to consider, what are the general guidelines we need to consider, what are the safety things we need to consider. There's a lot of things we have already considered in this huge module. So definitely it's useful. You need to remember all those values because it's a part of is going to be a part of your interview, you're part of going to be a selection. So you need to be very, very careful while deciding, selecting all these values when putting into the heat load applications. That gives you more confidence. As I already told that such material is not available on internet. So just make use of everything. Very limited resources regarding marine oil and gas are available on the internet. So I am one of them. So just take this opportunity, ask me questions what you have, and just ask me any questions what you have, and I'll be very, very, very glad to reply your questions. So just see you on the other side, and I wish to see you very, very successful in this field. The subsequent modules we are going to cover about the offshore platforms, which is very interesting, very, very interesting. You will absolutely blow with the information what I'm going to share you. So this is one of a kind course, so just be the part of it, part of this journey. And I've already explained you that oil and gas or marine engineers, they almost earn 10 times of the normal HVAC engineers. Yeah, believe me, we earn almost 10 times of the normal HVAC engineers. Like if I'm doing consultancy now, I'm earning enough money, huge money. So just take an opportunity to learn, be one of a kind, go to the places, go to the world, because this by this you can go to Gulf, you can go to Middle East, you can go to Southeast America. There are a lot of opportunities everywhere available. There's a shortage of people, so take an opportunity. Just jump into this field and focus it, and you can make a bright career out of it. Wish you very good luck, and just be with me for the next models also. Thank you.